What if you could delegate complex financial tasks to an AI, but with ironclad security and privacy? That's the problem Newton Protocol is here to solve. You see, traditional on-chain automation is risky. You either give a bot full access to your funds, or you have to manually approve every single transaction. It's clunky and it's dangerous. Newton Protocol changes all of that by combining three core technologies: zero-knowledge proofs, trusted execution environments, and zkPermissions. These three elements work together to create a new layer of verifiable automation for the web. Zero-knowledge proofs, zkProofs. First, let's talk about zero-knowledge proofs. Imagine you're at a party and someone claims they know the combination to a secret vault. To prove it, they don't tell you the combination. Instead, they lead you to the vault, open it, grab the treasure, and give it to you. You're now convinced they know the combination, but you still have no idea what it is. That's a zkProof. It lets you prove you know something without revealing what that something is. In the context of Newton Protocol, this means that an automated agent can prove to the network that it executed a task correctly, like rebalancing a portfolio, without revealing your personal transaction data or financial strategy. It's proof without exposure. Trusted execution environments, TEEs. Next up are trusted execution environments, or TEEs. Think of a TEE as a secure, virtual vault built directly into a computer's hardware. Inside this vault, data and computations are completely isolated from the rest of the system, even from the operating system itself. Newton Protocol's agents operate inside these TEEs. This ensures that any actions the agent takes are tamper-proof and private. The agent can process sensitive information, like your specific portfolio allocation, in a completely secure environment. Even if the computer running the agent is compromised, your data is safe. The TEE provides a crucial layer of hardware-level security, guaranteeing that the agent is behaving exactly as it was programmed to. zkPermissions. Finally, we have zkPermissions, which is where the magic really happens. This is the programmable rulebook for your automated agents. Using zero-knowledge proofs, you can set up highly specific, complex rules for what an agent is allowed to do. For example, you can grant an agent permission to buy up to $500 of ETH when the price drops below $2,000, or rebalance my portfolio to a 60/40th split between ETH and BTC, but only if the total value is above $10,000. The key here is that these permissions are cryptographically enforced using the zero-knowledge proofs we discussed. You're not just telling the agent what to do, you're giving it a verifiable, auditable set of constraints that it can't violate. So, when an agent wants to execute a trade, it first proves to the network, using a zero-knowledge proof, that the proposed action is in compliance with your specific zkPermissions. This all happens within the secure confines of a TEE, making the entire process transparent and trustless. In summary, Newton Protocol uses TEEs to provide a secure environment for its agents, zkPermissions to give users fine-grained, verifiable control over those agents, and zero-knowledge proofs to cryptographically prove that every action is both correct and compliant with your rules, all without ever revealing your private data. With that said, thanks for watching, and until next time.